And here's one more problem from section 1.5. This is number 41. Y equals the log of the base 2 of x plus 1. So we wanted to graph that. So again, this is a little bit easier than 39. It looks like we have a nice basic equation here, except we just have a shift here over here. And that's going to be to the left 1. That's all we have to deal with. So we can get some points for the shape equation. Now, again, this might elude you. It might be panicky, but all we have to do is change this to an exponential equation. Okay, so if y equals log of the base 2 of x, all right, this is my base, this is my exponent, and that's my answer. So I just make a table of values, and we've done this. We've used 2 to the x when we graphed this, so it's pretty easy. And again, we'll just use a few points when y is negative 1. 2 to the negative 1 is 1/2. When y is 0, 2 to the 0 is 1. When y is 1, 2 to the first power is 2. When y is 2, 2 to the second power is 2 squared, or 4. So we've got some points. We're just going to shift these over. So I'm going to go 1 to the left. So I would just subtract 1 from each of these x values. And that's all it would be. So this would be negative 1/2, and negative. This would be 0, 1, and 3. All I have to do is do that and put your points down. So that's a lot easier. So let's try that. So again, normally the log function is going to look like this, but we're shifting it over. So when y is negative 1, which is down here, I'm to subtract 1 from 1/2, and I get negative 1/2. Okay, and then when y is 0, instead of having 1, I've got 0. Just subtract 1 from 1. And then when y is 2, I'm sorry, when y is 1, pardon me, when y is 1, I'm going to make this is going to be, subtract 1 from that, so I'm going to get 1. Looks like I made a little error here. And then when y is 4, oh, I'm sorry. That's what, yeah, when y is 1, good. And then when y is 2, I'm going to have 3. Something like that. Okay. I started writing down the wrong points over there. And we can get another point. What happens when y is 3? Well, what's 2 cubed? 8. But I'm shifted over, so I would subtract 1 from 8. I would get 7. So I could put that over here. So this is when y is 3. This is going to be 7. So there we go. All right. So we can kind of check this out here. And it's going to be asymptotic. Normally the line is going to be y equals 0. I'm sorry, x equals 0, the y-axis. So this is the asymptotic line here. So I can always put that in. That might help you. So normally the logarithm, any logarithmic function is asymptotic in its native form to the y-axis. So now this is going to be shifted over. So this would be my asymptote here. Like that. So it's going to approach that, but not equal it. So we get down here closer and closer to that. And then we connect all these points. Okay. Now it looks like that. It looks like the domain is negative 1 to infinity. Because I'm not going to hit negative 1, so it's going to be open. It's because of the shift. And then the range is going to be negative infinity to positive infinity. All right. So let's check that on the calculator. And how are we going to graph this? Well, we're going to use the change of base formula to graph this on the calculator. So the change of base formula would be the log to the base 2 of x plus 1. That would equal the natural log of x plus 1 over the natural log of 2, because we don't have a base 2 on our calculator. So we'll use the change of base formula. And we'll use natural logs, just because it's shorter. So let's graph this and let's put this in our calculator first. So you can see it here better. There we go, I guess you can see that. And then we'll go y1, and we'll put the natural log, and then x plus 1, x plus 1 squared divided by the natural log of 2. And that's how we could graph it, and hopefully have the same window. So there's my same window, and that's what it looks like. Oops, let me put what we had. And looks about the same, doesn't it? And you could always check some values. Remember, just to check, remember I said when x is 7, we should get 3. So we can always just check this. Let's go second calculate, and value, enter. And let's say when x is 7, what do we get? Y equals 3. Okay, just like we worked out in our table. And when x is 3, enter. When x equals 3, what did I have? I had 2, enter. That says y equals 2, you see, etc. So we can get all those. And even go back and say second calculate, enter. When x equals negative 1/2 or negative 0.5, y equals negative 1. Okay? So all those values checked out, our table checked out. We didn't have to use the calculator, so you want to be able to do these without the calculator. So think about these. And the logs are the hardest ones to get shape equation values, because you know, you have to transform it over to an exponential equation, and then put your y's down and then find your values of x. Okay, hope that makes sense.